should recognize this from, say, grade 8 and grade 9, grade 9 especially. So I don't know about this middle column for substitution, but essentially all you're doing when you have the x is you're substituting the x to get the y, right? Because the y depends on whatever the x is. So if I substitute negative 2 in there, I'll show my work for this, but really, you know, you don't have to show this step. 4 times negative 2 is, negative 8 minus 3 is, negative 11. You keep going. Negative 1 goes in there. What do we get? Negative 7. 0 goes in there. What do we get? Negative 3. 1 goes in there. 1. 2 goes in there. We get 5. So they're just saying you're probably going to just do it like this, right, instead of showing your work here. And so what do you do with this table of values? You plot it, and then you see what it forms. Does anybody know what it's going to form? It is going to, well, I guess two things. We are in the linear relations unit, linear functions. But do you see for every x that increases, the y's do what? Increase by 4. Now, did you remember from grade 9, the increasing by 4 for every x? Do you remember that had a significant play on the equation? Yes? Does this ring a bell? And then what was this significance in the equation? That was the starting value when it was at 0. Yes? Does this ring a bell now? Okay, so what about if you see y equals 3, how were you taught in grade 9 to deal with that? That means y equals 3 no matter what your x is, yes? So if you want, you can just put a bunch of 3's there and then pick 0, 1, 2, or whatever. Did you like 0, 1, 2 as your x's last year? Yeah. And then what does x equals negative 5 mean? Yeah, it's yeah, so in this case, x is negative 5 no matter what. So you have to put negative 5's in for x, and for your y's, you can pick whatever you want. Now, does anybody remember what this would graph versus this one? Y equals 3. Which one's vertical, which one's horizontal? Yeah, this one is horizontal, very good. And this is vertical. And does anybody know the name of this kind of line here that has a little bit of diagonal to it? Oblique, yes. This is called an oblique line. Remember that term from grade 9? Okay. So I'm going to give you a second to complete. I'm going to give you I only want you to do 3 values, 0, 1, and 2 for your x. Don't worry about the substitution. It's up to you if you want to show your work there. Otherwise, I just want your y. So I'll give you a couple minutes to do that. Not even a couple minutes, a minute. Okay, so 0 goes in, I get 4. 1 goes in, I get what? 7. 2 goes in, I get 10. Yes? And what's the little like check system to know that you did it right? Kind of a check system, a check and balance. If you go up by 1s on your x, you should see a pattern going in your y's. And what's that pattern? They're going up by 3, and you knew that because that's a positive 3 there. Okay, so let's do this one. You get 5, you get 3, you get 1. Is that what you got? Okay, and what's my check system? X's are going up by 1s. The y's are going down by 2s. Okay, so the graph of a linear relation is so the graph of a linear function is a straight line. I hate using the word straight line because all lines are straight, but for example, this graph represents a linear function. Do you see if you connect the dots, you could have a ruler that goes right through it? No, because you could have a vertical or horizontal too, right? So do you see that for every 2 that the x goes up by, my y goes up by this similar amount? It doesn't have to be the same, For instance, this is going up by 2. This is going up by 6. Okay? So you should see that pattern in a linear relation. For everything that goes up by x, the y should go up or down by a constant amount as well. So for a linear function, when the changes in the first column are, I think I want constant, the same, from one row to the next, the changes in the second column are similar. I don't know. I don't think I want similar. Are the same. I'm going to put all the same. I don't like. Yeah, I crossed out the and put similar. I don't know. Sometimes when I put words there, I don't remember what I took out, which is kind of troublesome. Okay, so let's look at these table of values. This will be on the test, right? So do you see your independent is going up by 2's? Okay, so if this is a linear relation, this should go up by a common amount as well. So I'll say this is going up by 2's. And what's happening here? Is it squaring? Yeah, it looks like it's timesing by 5 each time. So is this considered a linear relation? No. Guess what this is called? No, oblique is linear. I heard somebody saying squaring. This is actually, and you'll learn this in not till grade 12, this is actually an exponential function. An exponential function. And the reason I know that is it's like 5 to the power something each time, right? This is 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3, 5 to the power 4. Do you see why it's an exponential function? Okay, you wouldn't have to answer that on a test, but I just thought since you guys are so smart, I might as well tell you some good stuff like that. Okay, so do you see, again, the x, or the independent, in this case the time, has to go up by a common amount. It's going up by 5. Doesn't have to go up by 1s, but it has to go up by a common amount. So what happens here? It goes up by 3. Can anybody come up with the equation of this? Just for fun? Volume equals, so yeah, this is linear, right? Can anybody come up with the equation? I hear 5t plus 3. No, I hear 3t plus 18. The only thing I heard correct so far is the plus 18. Now, you wouldn't necessarily know this. I would agree the 3 is part of it, but it's actually 3 over 5. And the reason why is in the past, in grade 9, when we were coming up with this number that's multiplying by the independent variable, the x's were actually going up by 1s. So this is where grade 10 changes, and you have to come up with that. So don't worry if you couldn't get this. I just thought it was a good place to start talking about it. Okay. Are you here? Yeah. Okay, what about this one? Y equals x squared minus 1. Do I need to do a table of values to figure this out if it's a linear relation or not? My first guess is, what do you think it is? No, why? Because what? There's a square in there. Does anybody know what that's called? Some people refer to it as a squaring function, but this is actually what's called a quadratic function. And you will learn about quadratic functions in grade 11. Okay, so just to see if this is linear or not, do you see my x's are going up by 1s? If I put -2 in there, here's a mistake a lot of people will make. They don't realize they're squaring the negative as well as the 2. So really this means -2 times -2 subtract 1, right? So what do I get there? Yeah, 3. I get 4 and then subtract 1. Same with this one. This is -1 times -1 and then subtract 1. What do I get? 0. So at first glance you think, oh, it's going down by 3s. 0 goes in. What do I get? Negative 1. Do you see it's not going down by a common amount now? 1 goes in, what do I get? Look at it, went back up again. You might think, oh, I must have made a mistake. No, one of the features about a quadratic function is it looks like this. It's a parabola looking shape. Yeah, so 2 goes in, you get 4 minus 1 is 3. So do you see these actually start matching there? So it's not a linear function. Yes? Yes, you'd have to answer yes or no. No, you don't need to say, oh, this is a quadratic or an exponential. No. Yeah, if you have a square anywhere with the variable, definitely not a linear function. And if you haven't figured out, a linear function is in the form y equals something x plus something. Okay, so this is an oblique is in this form. Do you remember this from grade 9? And then if it's in the form x equals whatever, that is what kind of line? Like x equals 5 or x equals 2? Yeah, a vertical. And if it's just y equals whatever, that is the horizontal. So that's the form that y lines take. There is no, it's x to the power 1 there. It's not x to the power 2. It's not x to the power 3, nothing like that, right? Okay. Oh, now they're saying to plot this. So negative 2, 3, negative 1, 0, 0, negative 1, 1, 0, and 2, 3. So do you see it actually goes like this, hey? How did I know I could actually connect the dots there? Is this a discrete data? No. Although I picked negative 2, negative 1, 0, I could have picked any points in between those, right? Exactly. So do the points lie on a straight line? No. So does it represent a linear function? No. Okay, so now we're going to go y equals x plus 2. Does anybody want to make a guess whether this is a linear relation or not? You want to make a guess, or yes, it is? Yes, it is. Yeah, it is. So I don't know. Do we need to come up with this? Well, negative 2 goes in there. What do we get? 0. Negative 1 goes in there. What do we get? 0 goes in there. What do we get? 1 goes in there. What do I get? 3. Am I losing anybody going this fast? Okay, so let's just go negative 2, 0, negative 1, 1. You can see it all forms a nice, beautiful line here. Do you see? Does everybody know on a line, when you graph it, you're supposed to have arrows at the end of it because it goes on forever, right? So does it form a straight line? Yes. Does it form a linear function? Yes. We've seen that linear functions involve variables changing at a constant rate. We can find the rate of change, and I want to abbreviate it ROC, of a linear function. And that is the change of the dependent divided by the change in the independent. Sometimes, I don't know how far you are in your science, but you might see it also delta y over delta x. Have you seen delta before? Yeah, that means change. So you're changing your y over your change of x. It's just abbreviation. Okay. Change. Yeah, the difference between. So for instance, if the x went from 5 to 3, the change would be 2. If the y went from, say, 10 to 2, what would the delta be? 8. And so then you would take 8 and divide by 2, and you would get 4. So that means the rate of change is 4. Okay? So it says the dependent variable is plotted on the y and the independent on the x. And I think everybody knows that already, right? Okay, so now we're going to find the rate of change. So you're going to look at this graph. Do you see it has an endpoint there? That means it doesn't go on forever or anything like that, right? Okay, can anybody tell me the dependent and the independent? Which one is the dependent variable? The variable. So it's your choice is T or A. It's A. And your independent is t. And if you had no idea, if it's on a graph, it's pretty obvious. The x is always the independent or the horizontal, right? And your y is always your dependent. Okay? So now we need to find the change or the rate of change. So remember, rate of change, ROC, is equal to the change of y over the change of x. So you can pick whatever points you want to find the change. A lot of people might pick the first two dots here. Do you see? From here to here gives you a change, and from here to here gives you a change. This would be your change of y. This would be your change of x. Does everybody know what I'm measuring there? So what would my change of y be? 120. And what would my change of x be? 60. And so I get what? 2 what? What would the units be? Meters per second, actually. Do you know what that represents? Well, yeah, it represents the speed. Yeah, the speed or the velocity. Okay, so I'm going to show you a different way. I'm going to do it in red here. Does everybody see I could use this one and measure it? Do you see what's the change here for my y? 240. And what's my change here? 120. Do you see I would still get 2? It doesn't matter which 2 points I pick. I could also pick these 2 points, right here and right here. It's a little harder to get, though, because this would be a height of 240 to 120. So this one would be 120 this way, and this would be from 120 to 60, so it would be 60. But either or, you get 120 divided by 60, and you still get 2 meters per second. Do you see? Doesn't matter which 2 points you pick. Okay? By the way, if the line is going up to the right, my rate of change means it is positive. If it's going down, that means it's decreasing, which means my rate of change is negative. Make sure you put those signs in because those are important, okay? So, oh, look at that. Now it's going down to the right. So guess what our rate of change is going to be? Negative. Okay, so who can tell me what the dependent and the independent variables are? Yeah, so I'm going to put distance and time. Very good. And I'm going to give you a second to figure out the rate of change. Whoops. You could do that. Or you can do this big thing here. From here to here to here to here. Whatever you want. Anybody got a rate of change yet? Negative 60, yes. And what would the units be for that? Kilometers per hour, very good. Okay, so I'm going to do a bunch of different ways. The big triangle is probably the most obvious. It's going from, again, remember, it's change of y over change of x for ROC. And because it's going down, technically my y is negative then. So that's where I'm getting the negative from. So negative 180 divided by 3. So I get negative 60, and that would be kilometers per hour. And that is speed, right? Again, if you take distance and divide by time, that's your speed, right? Okay, I could do green. Does everybody see green? This would be 60 here. This would be 1. So 60 divided by 1. Did anybody take another point? Or you all got 60? Yeah? Okay. Any questions on rate